Welcome to your Introduction to Statistics, Unit 3, Elementary Probability Theory, Lesson 1. Today we're going to find probabilities of simple events. So probability, what is it? Probability is a numerical measurement of the likelihood of an event, the chances that it will happen. Probability of any event is a number between 0 and 1. So if it's impossible is 0. If it's absolutely certain, the probability is 1. So events with probability close to 1 are more likely to occur, and events with probability close to 0 are less likely to occur. So we need to talk about some notation. If A represents an event, capital P and then in parentheses A, usually we use capitals to represent events, so capital A represents the probability of A. Like I said earlier, if an event is certain to occur, the probability of that event is equal to 1. If the probability of an event is equal to 0, that means that event is certain not to occur. There's 3 methods to find probabilities: intuition, relative frequency, and equally likely outcomes. Intuition method of determining probability incorporates past experience, judgment, or opinion. It is based upon a level of confidence in the result. For example, I'm 95% sure that I will attend the party. Well, there's no way of determining that for sure. It's just based on your intuition. Probability as relative frequency means that the probability of an event is equal to the fraction of the time that the event occurred in the past. So if F is the frequency of the event and N is the sample size, it's F over N. So the number of times the event occurred divided by the sample size. So an example of probability as relative frequency is if you note that 57 of the last 100 applicants for a job have been female, then the probability that the next applicant is female would be 57 out of 100. Sometimes we can use equally likely outcomes, and this happens when no one result is expected to occur more frequently than another. So this happens sometimes. This doesn't happen all the time. You have to have some knowledge about a specific scenario to be able to state that. If that's the case, when individual outcomes are equally likely, the probability of an event is equal to the number of outcomes favorable to the event divided by the total number of outcomes. So, for example, here, when rolling a die, the probability of getting a number less than 3 is 2 out of 6, or 1/3. Well, why does that work? Well, there's 6 total outcomes, and each one's equally likely. Each outcome is equal to 1/6. If you roll a die and you get a 1, that probability is 1/6. Roll a die and get a 2, the probability is 1/6, and so on. The only 2 outcomes that are less than 3 are 1 and 2. So 2 out of the 6 outcomes make this a true statement, okay? Fit the event. And so the probability would be 2 out of 6, which reduces to 1/3. Now, there is something called the law of large numbers, which states that in the long run, as the sample size increases and increases, gets larger and larger, the relative frequencies, remember that method of finding probabilities? Anyway, the relative frequencies of outcomes get closer and closer to the theoretical or actual probability value. All right. Statistical experiment or statistical observation is any random activity that results in a definite outcome. An event is a collection of one or more outcomes of a statistical experiment or observation. And a simple event is an outcome of a statistical experiment that consists of one and only one of the outcomes of the experiment. A sample space is the set of all possible distinct outcomes of an experiment, and the sum of all the probabilities of all simple events in a sample space must equal 1, because something has to happen. And so if you look at all the possibilities and you look at their probabilities, they have to add it to 1 because something has to happen. So just to help you grasp the idea, the sample space for rolling an ordinary die, a normal 6-sided die, You can get a 1, a 2, a 3, a 4, a 5, or a 6. And so the way we write that is we use set notation, the curly brackets, and we just list all those outcomes. 1, 2, 3, 4, 5, 6. All right. For the experiment of rolling an ordinary die, the probability of getting an even number is 3 out of 6 because there's 6 total possible outcomes, 3 of which are even, 2, 4, and 6. And so that reduces down to 1/2. The probability that you have a result less than 5, there's still 6 possible outcomes. 4 of them would qualify for the event, the result being less than 5. You could roll a 1, a 2, a 3, or a 4. And so 4, 6 reduces to 2/3. Result, the probability of not getting a 2, well, everything except 2 qualifies. So that would be 5 of the possible outcomes, just kicking out 2 takes us down from 6 to 5 out of the 6 possible outcomes. The 5 that qualify is not getting a 2, and then 2 itself. All right, the complement of an event, A, is the event that A does not occur. So the complement of rolling a 2 is not rolling a 2. Notation for the complement of event A is A with a superscript C. Sometimes you'll just see like a little dash there, and a little prime kind of looking little guy. That's another way of saying a complement. Okay, so if we look at a Venn diagram, here is our whole sample space, all the possible events. If this is event A complement is everything outside of event A. All right, because the sum of all the events in a sample space has to be 1. If we do 1 minus the probability of A, you're going to get the probability of A complement. If we do 1 whole sample space, probability of the sample space, minus the probability of A complement, we get the probability of A. So the probability event A does not occur is the probability of A complement, and that's going to be 1 minus the probability of A. And again, that's because the probability of A plus the probability of A complement is 1. And that's because they make up the entire sample space. Okay, if the probability that it will snow today is 30%, the probability that it will not snow is 1 minus the probability of snow. So 1 minus 0.30 is equal to 0.70. Okay. So what are the odds? Odds and probability are related, but they're not the same thing. Even though you'll hear people use them interchangeably, they're not precisely the same. Odds in favor of an event is the reduced ratio of favorable outcomes to unfavorable outcomes. Odds against an event is the reduced ratio of unfavorable events to favorable events. Okay, so that's very similar, but it's different than the probability of an event. Okay, it's the reduced ratio of favorable outcomes to the total number, favorable plus unfavorable outcomes. So, consider rolling a die. What are the odds in favor of rolling a 2? So you need to consider the sample space, 1, 2, 3, 4, 5, 6. There is 1 favorable outcome, 2, and 5 unfavorable outcomes, 1, 3, 4, 5, and 6. So the odds in favor of rolling a 2 are 1 to 5. Okay, so what are the odds against rolling a 2? So again, you consider the whole sample space, 1, 2, 3, 4, 5, 6, and you divide up the outcomes into unfavorable and favorable. So there's 5 unfavorable, 1, 3, 4, 5, 6, and 1 favorable, 2. So the odds against rolling a 2 are 5 to 1. So what's the probability of rolling a 2? Well, you still consider the sample space, but this time you consider the favorable outcomes, so 2. So there's just 1 of those, and you've got to roll the 2. So there's 1, and then you compare that to the 6 total outcomes in the sample space. So the probability of rolling a 2 is 1/6. All right, probability related to statistics. Probability makes statements about what will occur when samples are drawn from a known population. Statistics describes how samples are to be obtained and how inferences are to be made about unknown populations. So probability and statistics aren't the same thing, but they are related because they both deal with samples and populations. Okay, guys, that's it for today. Go ahead and do the problems to try on your own. Thank you for taking great notes. I'll see you in class. Have a great day.